And with that, let's change gears and talk about HIV cure strategies. You'll recall a picture you saw earlier about the status quo in HIV therapy. Basically, we have antiretroviral therapy, we have induced latency, and that's where we are. So, is this good enough? As a society, as scientists, as individual researchers, we have to answer the question, should we try to cure HIV? So, should we? We have the option of maintaining the status quo, basically trying to increase the number of individuals on ART, but not trying to reduce the need for lifelong ART. Or we have the ability to try and develop a strategy to eradicate HIV from inside the body. So I'm using cure and eradication as synonyms here, so please don't be confused by that. I vote that we try to cure. I'm not satisfied to just sit with the status quo. We need to push the envelope forward. But how? It's very easy to draw an arrow on a slide saying, let's get from here to here. But how do you do that? What's the black box? How do we do that? I don't know. But let's just take a peek inside and see what we can figure out is going on inside this black box, at least a little bit. So we have this decision tree here. Talks about key challenges and decisions in this process. So do we try to cure HIV? If the answer is no, it's the end of the discussion. But if the answer is yes, then things are just getting started, right? Now you have to choose an intervention based on preclinical data. You have to know what preclinical data to use. Is it from animal models, non-human primates, humanized mice? Is it from cell line-based data? And is that enough information to move this intervention to the clinic? If the answer is no, you start over. If the answer is yes, well then you move forward. You then seek ethical approval for your intervention study, and at this stage, acceptable risk is determined. As I mentioned with the histone deacetylase inhibitor, when panobenostat opened the chromatin, she opened the chromatin for surrounding cells as well. There is risk associated with that, but ethical boards and the scientists have determined that, as well as the patients have determined that this risk is acceptable. These are drugs that are being used in cancer treatments already. We're just applying them in a different context, so it's not something that's completely new. But if the risk is deemed unacceptable, then you start over. If it's deemed acceptable, then you move forward with patient education and recruitment. If your patient participants decide that they are not interested in the type of study that you've designed, you start over. But if they are interested, then you perform the study and you do your analysis and you ask the question, did the study achieve its intended goals or endpoints? If the answer is no, you start over. More likely, the answer will be yes, partly, but refinement is required. If that's the case, then you start over. And only when you have a fully efficacious at this stage, then do you move into the next stage. There's 4 stages of clinical testing, 1, 2, 3, and 4. And what I'm talking about at the very earliest stages, but there are many further checks and balances in the process before it makes it into the clinic as an approved intervention. So what are the prominent HIV eradication strategies on the table these days? There's the gene therapy or specialized bone marrow transplant approach, where you have a donor. This donor can be a person that's distinct from yourself, but is genetically matched so that you don't have immune fighting within yourself after the bone marrow transplant. So you get this HLA matched donor, or you can donate to yourself. In certain circumstances, if you donate to yourself, you take these blood stem cells and you manipulate them outside the body through some mechanism, maybe to cause that doorknob to be broken, and then you put them back into the body. So has this been used? Well, there's one very famous instance of a bone marrow transplant in an HIV patient used in cure strategies. And that's in reference to Mr. Timothy Brown. He's also known as the Berlin patient. American, was living in Berlin, being treated for HIV, came down with acute myelogenous leukemia, I believe, AML, and went for treatment. So he's getting his treatment and it's just not working. And so his doctor, Dr. Gero Hutter, determined that he should get a bone marrow transplant. But he was very clever in his approach because he recalled something he had learned in medical school where he was taught that there are people that have deficient doorknobs. And these people are resistant to HIV. And he said, if I can just find somebody with a deficient doorknob that's genetically matched, maybe I can use them as his bone marrow transplant donor. And then see if that helps his HIV as well as helping cure his cancer. So he did find such an individual. Timothy Brown had the transplant and the cancer recurred. So he had the transplant a second time. Each of the transplants had extensive preconditioning regimens, more extensive than would be typical. And so you have preconditioning and you have a bone marrow transplant, and Mr. Brown very nearly died from this ordeal. The therapy was very, very toxic to his system, and in the process he actually had to stop taking his antiretroviral therapy. And when the doctors looked, the virus didn't come back. And since 2007, the virus still hasn't come back. Mr. Brown is the first individual that has been scientifically verified as HIV cured, to the best of what we can determine at this point. He's our proof that it is possible. And he got the specialized bone marrow transplant, a genetically matched donor, but it was a very special matched donor. It's not something that's scalable. It's not something that you can do on any grand scale. And in fact, Dr. Hutter has published again in 2014 in the New England Journal. He published that he's tried this on 6 additional individuals, and none of the 6 individuals lived more than 1 year. So the therapy in and of itself is actually very hazardous, but it serves as proof that it is possible to do something under the table and make that virus come up and have it be whacked. So this is just to bring you back to that point. But then we have the strategy for HIV cure that is actually the strategy we're evaluating here in Skybu in Aarhus. It's the kick and kill strategy. With a kick and kill strategy, you have a cell that has latent virus and you kick it with a histone deacetylase inhibitor or otherwise. It causes virus transcription, and then you have some kill agent come in. It destroys this cell. The cell goes away. The virus, because you have antiretroviral therapy around, the virus can't infect any new cells, and everything disappears. The goal of something like this is to have a cure where you have no antiretroviral therapy and no functional HIV. That's the goal. What are some possible kick agents that could be used in this context? We've met penobenestat, a histone deacetylase inhibitor. There are other histone deacetylase inhibitors that can also be considered, romidepsin, vorinostat, for example. There are PKC agonists, or activators rather, like prostatin or bryostatin. Some possible kill agents include therapeutic vaccines, maybe immune adjuvants such as toll-like receptor agonists, and then perhaps the passive immunization, so taking antibodies that you know can destroy or bind to the virus from the outside on its envelope and prevent it from entering cells. So you maybe could combine something like that with other agents to kill or perhaps even kill cells that have viral envelope on their surface by binding them and inducing ADCC.